Hello, today we have an episode on network security and DDoS attacks mitigation. More specifically, we'll talk about BGP Flowspec on NCS 5500 and integration with Arbor Networks solution. More after the break. We will split this video in two parts. First, we will talk about BGP Flowspec principles and how we configure it on iOS XR. In the second part, we'll run a demo with a Memcached amplification attack. It will be detected and auto-mitigated with a solution composed of an NCS 5500 on one side and an Arbor Networks SP on the other side. But let's start with a few words on BGP Flowspec. If you want more details on the technology, I will let you watch the CiscoLive session presented in Las Vegas in early 2018. It contains all the details you need to understand our implementation. To summarize what BGP Flowspec is and can do, I would say it's a mechanism used to influence remotely the forwarding plane of a routing device. It has been ratified in 2009 with 2 RFCs, and for once it's an easy read. In this case, BGP is used to transport what we call rules between a controller and clients. These rules are made of two elements. A description, that's a field coming from the layer 3 and layer 4 IP headers that we will use to identify specific packets. For example, address and port, source and destination for UDP and TCP, ICMP type and code, but also TCP flags like SYN, ACK, reset, packet length, DSCP field, and fragment indicators. The second element is an action. It describes the treatment of the packet matching the former description. We can rate limit or drop a flow, we can divert the flow to a specific address or a different VRF, and we can remark the DSCP value. In a BGP Flowspec architecture, we have a controller or server. It contains a control plane where will be originated the rules. It's basically the brain of the solution. Second, we have the client. It does have a control plane too to receive the rules, but also it contains a forwarding plane part to program the hardware. The client is the muscle here. It will influence the traffic based on the controller's recommendation. Optionally, it's possible to use a route reflector for better scalability when you have a lot of clients. Something important to mention. By nature, BGP Flowspec is unidirectional. That means there is no feedback loop providing information on the impact of the rules you applied on interfaces. Nothing in the protocol will send details on the number of packets that have been matched and dropped by the rules. This information must be collected via different tools. Flowspec is commonly used inside a given autonomous system, but as the name implies, it's BGP-based, and therefore the common propagation rules for internal and external BGP will apply. But in real world, we see very few cases for inter-AS usage of Flowspec. Before we move to the configuration, I need to mention a feature which will simplify your designs significantly. Packets targeted to 10.0.16.51 are flowing from left to right following the best route available in the RIB, a /20. A BGP Flowspec controller injects the rules diverting the traffic targeted to the same /20 to another device. The Flowspec rule will take precedence over the routing, and the packets are diverted to A. If A is a system on a stick, like a DPI appliance or a DDoS scrubbing device, the packets are stuck in a routing loop until we reach a TTL limit and we drop them. Several routing tricks based on VRF Lite exist to address such a situation, but now we have a much more elegant solution. This iOS XR implementation gives the flexibility to decide which interfaces are enabled or disabled for Flowspec. So, if you disable it for this interface facing device A, when the packets are coming back, we don't use Flowspec, but the natural route to B, and we bypass the routing loop. Okay, now you understand the basic principles of BGP Flowspec, let's check the configuration. The controller device is the Arbor Network SP. The client is an NCS 55A1 36H SCS. It's a 1RU system based on Jericho Plus and external TCAM running iOS XR 651. The attack traffic will be received on 10 gig interface 0000. IPFix is configured with a sampling interval of 1 for 1000. The monitor map defines a cache of 1 million entries and an active timeout of 10 seconds. We see here the export map is indeed configured for IPFix, and we verify that our configuration is applied and operational. Now, let's take a quick look at the BGP configuration part. Here, the neighbor address represents our Arbor Network controller, and we simply need to position an address family's Flowspec at the router level and below the neighbor statement. Finally, under the Flowspec part, we see it's applied to all interfaces. And that's it. Nothing more is needed on the router, and we are now ready for the demo. In the next video, we will show you how NCS 5500 can interoperate with Arbor Network solution. We will mitigate automatically a Memcached attack, and we will demonstrate it's not necessary to perform deep packet inspection for this kind of attack. It can be addressed very efficiently with BGP Flowspec. Thanks for watching. See you very soon in the next video.